Hi, John Capobianco, and I'm back with some more MCP. So please watch the first video. There's not going to be a lot of context for you to understand what I'm talking about in this video if you didn't watch the previous video. Or you could try to follow along. It's up to you. So we had a standalone MCP server for my LangGraph server. All right? And we wrote a client so we could communicate with the MCP server. This solution, the client, is a Python script. So we do Python 3 mymcpclient.py, and it takes two arguments: a prompt, what can you tell me about this packet capture, and a packet capture. Now, what's interesting is the words and the terms and what we ask it and how we prompt it will trigger different agents and different tools. If we just want to know what the source and destination IP is, that's fine, it will tell you. If you want to say, and tell me more if you find a public IP address, it will start to run different tools. You can ask it to ping specifically. If you find a public IP address, could you do a trace route to it and show me the results? Or give me a deep analysis and it'll run all the tools. That was and is the MCP server for the Selector Packet Copilot. Now, here's where it gets interesting, and I alluded to this in the previous video. What if we go MCP shopping and go look for other MCP servers? We don't even need clients, just servers. Now let's get to the Excalibur where I can hopefully make some sense of this for everyone. So again, we're talking about the model, context, protocol. 3 minutes of your life. This is only since November of 2024. And things take a while to percolate. Things take a while to sieve down into people like my hands and my attention and my exploration of this new protocol. Again, protocol. Here, for anyone watching that's a network engineer, routing information protocol, border gateway protocol, different protocols. And instead of routing, it's model, and instead of information, it's context, right? So what the protocol allows us to do is use natural language context backed by large language models in a controlled, documented, ratified standard that under the hood lets people build on top of it with confidence and allows us to interconnect things. Just like RIP lets us connect routers in 1988. Now, in 2025, we can connect artificial intelligence agents. Okay, enough of that. This was from the first video. This was the original way that I had everything set up with LangGraph. And the user would visit a Streamlit front end, or the user would do various ways of interacting with the API. This LangGraph triggers this assistant and the tools. We report into Langsmith. Some of this has not changed. However, we're going to focus in on this section. Okay? And by the way, the tools are all enumerated down here from yesterday. All right, so we're going to focus on this aspect right here. MCP to MCP and our server. All right, so I'm going to add something that I've learned here, this line, to that MCP server. So if I zoom out a little bit, and let's redraw some of this in a new section on what I've sort of learned here. We're going to use the diamond to represent our, in my case, I'm just going to stick with LangGraph. This is my LangGraph. And don't forget we have, this calls that workflow down here. The assistant, the tools, all that stuff. Okay? In front of this, we've put an MCP server. All right? And now the MCP server talks to the LangGraph again via that natural language. So now if I zoom over here, and by the way, I have not got to this yet, but There's no reason why I still can't reuse my Streamlit front end. Or we have our user with their script or their code, their client, right? So I'm going to add server here, right? This is the MCP server, and this is the MCP client. All right, so we have a client talking to a server. Now, what's interesting to me is that we can just simply scale, and I'm going to do this. We just simply do this. We just keep adding more and more and more and more servers that we then just have to stitch together from our Lang graph. Now, what's assumed here is that every one of these servers, right? Every one of these servers is like my server. And they have tools and agents that can do different things, right? And now this becomes the World Wide Web. This becomes W. But instead of connecting web servers and web clients, browsers and servers, HTTP servers, right? Which evolved into REST APIs over time. And now we've evolved into natural language and agents and tools, right? So this is very much in line with what other leaders in this space are talking about. I'm going to give a shout out to Dwan Lightfoot, my good friend, who I've done a lot of work with over the years, and I highly respect, right? He is talking about this. Jeremy Schulman, one of my mentors, a longtime friend from a very long time ago in the Ansible days and network automation. He is very interested in MCP. So I have a lot of encouragement. I have a growing community. Now, let's move into some cool things. How do we go server shopping? Well, we just go to modelcontextprotocol.io. Whoops, I didn't mean to click that. Modelcontextprotocol.io, and we go to example servers. And I did this sort of already, but we're going to look at development tools. And specifically, we're going to look at GitHub. So this is all we need. This is the MCP server, and hey, look, it has tools, including the create or update file tool. And what are its inputs? Now, be very clear here. These are not necessarily inputs that the user has to worry about, like a REST API call and a body of a post and all of that. These are going to be recognized through natural language. All right? So that is the server. And I'm going to show you some Langsmith tracing. And I have a couple of other tabs open. I've got some pretty special stuff going. So now it's time to jump into the code. Before I do code, I always like to talk about the infrastructure and the architecture. This is extremely Docker heavy. Now, this is my Docker Compose, and you're going to see that I have my own MCP server for the Packet Copilot, and I have another MCP server for the GitHub MCP. All right, the other Docker Compose files that are made up in here is an SMTP server that I've built for email and my Streamlit front end. All right, now into the Docker files, you can see that I have a Docker file for my Streamlit, for my SMTP, for my MCP, for my GitHub MCP, and for my Docker file. Now, we're going to look at the one I built. Now, this is mine. A bunch of pip installs all of my LangGraph stuff because it is a LangGraph server MCP integration. All right? Now, for the GitHub integration, very small, and we are using NPM and Node.js. All right, this happens to be a Node implementation, as you can see by the index.js and the node. So we're running a Node.js node, and we have the source files here. So there is an index TypeScript file, a tsconfig.json file that you're going to be building your Docker file from. All right, that brings up your server. You now have an MCP server for GitHub, which is part of my source now. Again, I have various packet captures. I have some Streamlit config. I have my tools. These are all the tools that are available to my assistant. All right, these are the little AI agents, if you want to think of them that way. Things that can curl a public IP or an IP, one that can do email, my primary RAG file, okay? All the tools that you need. Let's look at the MCP server first. Okay, and this is a huge file, so I'm not obviously going to read all 250 lines of code, but these are all asynchronous functions. And if we go to the imports, we're going to be using fast MCP. All right, so from MCP server, fast MCP, we're going to be bringing in the fast MCP server. All right, very important. Now, you're not going to see requests in here or curl or anything. It's all HTTPX, it's all async, it's all AIO. All right, the servers themselves are not typical REST servers. They actually use SSE, and they actually use, RPC calls, JSON RPC. All right. Now the client, right, shows the usage, Python 3, MCP client.py, the user's question or prompt, and the pcap file. All right. Most of this is the base64 conversion and the analysis results. Very tiny little client for the MCP server. Now, I don't have any Python or code that I've had to write for the GitHub MCP server. I got its source code, I got the Docker file, and I've integrated into my Docker Compose. My client was not modified whatsoever. This is a client for my MCP server. Now, what was modified was the packet copilot, my lang graph. So if we go to the bottom of this file, the lang graph itself, and I'm going to show you from where down it didn't change. From here down, I didn't touch my assistant. I didn't touch my graph whatsoever. Nothing changed. The only thing that changed was that I added a create GitHub report tool to my list of tools. And then I had to integrate that tool from the MCP server, which is a little bit of code here. But this tool uses the GitHub MCP server. Now, I'm going to come back on full screen because I think this is important and I want to highlight something here. Whoops, hang on, wrong button. No code. I did not write any code for the MCP integration. I took the Git stuff, I made my own container of it, and I integrated it into my lang chain, or my lang graph tools. My lang graph tools. That was it. Remember, assistant tools. Now, it can do a cross-communication call to an MCP server for Git to implement that tool. And they've implemented it. It's part of their MCP. It's a protocol. A protocol. I don't have to worry about anything as long as I adhere to the protocol. MCP to MCP, I've scaled it out to now talk to Git. I hope that has an impression on you, okay? So let's go back to it. Now, what we're going to do is we're going to run this thing. So we're going to close all this down and we're going to actually run it. So we're going to bring up the server here, which is just a simple Docker Compose up build. And I do the build in case anything's changed, and nothing should have changed. Access to... I'm sorry, that was weird. I just about panicked there, like, what? So anyway, a weird error there. So it's going to go ahead and build. This might take a little bit of time. So I'm going to pause here, and I'll come back as soon as this is done building. Okay, everything is compiled, And here we go. So this is to show you what's all being built here, right? So MCP server for my Packet Copilot graph. The SMTP server, my Streamlit front end. All right, now we've also created some other containers down here, the GitHub MCP server primarily. All right, now we've attached to everything, and you can see my Packet Copilot graph starts, and then my SMTP server starts. Whoops, wrong key. Let me go back to that. And then my MCP server from GitHub starts. Now I've put some logging, because we have access to the source code, and I'm pretty handy with TypeScript, JavaScript, whatever script. I just put some logging in so I could see what was going on inside of the MCP, because I didn't write the code and I don't really know what's going on in there. So these are the logs that are pretty handy to have. And then my Streamlit starts up, and my MCP server, right? Not the Lang graph, but the MCP server that sits in front of it. It starts up and connects out to my Packet Copilot graph, connecting to LangGraph and that API. Now I dump it out with the tools that it's initialized with. Now this MCP server has initialized with the creator update file from the remote MCP server, in addition to my own tools. But that's what I wanted to log out, that it did register the foreign tool. Now let's call it that, the foreign tool. All right, LangGraph server starts up, everything's happy and healthy. We're listening and we're good. Now, how do we interface with this, John? What are we supposed to do? Well, all we need to do is type Python 3 MCP client, and then our prompt. And what we're going to say is, what is the source and destination IP in this packet capture? If you find any public IP addresses in either, could you perform a deep analysis of the IP address? Further, once you are completed your analysis, please go ahead and send a comprehensive report to John Capobianco at, and let's just put my email address here, and please create a report with the date and time and a title summarizing the analysis on AutomateYourNetwork on GitHub in a repository called, I think it's called Packet Conversations. Now, before I do that, a couple of things. I'm being very verbose on purpose here. This is for demonstration purposes. There's a lot of ways to crib this and have very brief conversations. Also, I just want to make sure I get the name of my repository right. So, let's see what this thing can do. We're going to put it in quotes and say capture.pcap. So again, Python 3 MCP client.py prompt, a complex prompt here. What's the source and destination IP of this packet capture? If you find any public IPs in either, perform a deep analysis of the IP address. Further, once you're completed the analysis, go ahead and send a comprehensive report to John Capobianco at ptcapo@gmail.com. And please create a report with the date and time and a title summarizing the analysis on AutomateYourNetwork on GitHub in a repository called Packet Conversations. capture.pcap. Now, what do you think? What do you think is going to happen? Do you think this is going to work? Do you think this is the new way we're going to interface with computers? Now, I could easily turn this into text-to-speech and just say, MCP client and whatever. But for now, I'm typing it. So, pretty ambitious, pretty cool stuff if this works. Now, this is all because of the protocol. It's a protocol, and it is for models context. This is the context that MCP server is going to deal with. This context window that I'm sending it. I'm sending it a context window, and it is going to then invoke the tools, local or foreign, that it has available to it. So we're sending the query. There's the PCAP. There's the thread that was created for logging purposes. Here we're sending the analysis request. For logging purposes, I've dumped out anytime a tool has been called, and the tool and the data that's been passed to the tool, just so that I can keep track of it in a log, also for demonstration purposes. So you can see it starts with the RAG tool, which makes sense, and then it's doing some other analysis. It's running other tools, it's going back to RAG, it's running more tools. It's just created the GitHub report, and we're going to go look at the GitHub report. Through the foreign tool, through the GitHub MCP server. Now it's sending the email. And here's the answer back to me as a human here in the script. Right? So final answer. The analysis of the packet capture is complete and a comprehensive report has been created. Here's a summary of the packet analysis. Source 192.168.261. Correct. I can show you the Wireshark, a private IP, and destination IP. A public IP belonging to WebEx. Okay, so that's right, because of the tools and because of all the information gathered, it's able to, tell me that belongs to Cisco WebEx. So this is a WebEx packet. Who is, location, threat assessment, network connectivity. Report created. View the report here. It even gives me the hyperlink. No way. No way. Let me try it. Okay, I was not expecting. Comprehensive IP analysis report. Okay, let's go back to the log. Let's finish the logs here first. Wow. Email sent. If you have any more tasks or need further assistance, please feel free to ask. Well, isn't that handy? Now, let's look at the report we get inside of Packet Conversations, PCAP report, September 5th, 2023. Now, why that date? Because that's the date of the packet capture. This analysis is focused on the packet captured on September 5th, 2023. So it even named the file PCAP report on that date in Markdown, so it looks all pretty like this. Look at all this stuff. Conclusion. Now this is in GitHub. This is version and source controlled. That file is there. This is a public repository. You could go visit and read that file right now. I'll put a link in the video. All right, you watched me make it with MCP. Now, we're not done. We're not done. We should have an email sitting here. Yeah, inbox 1. John C. Here's the email. And it's even different words and stuff, right? It's a whole different thing. I hope this email finds you well. Please find the comprehensive report on the packet capture analysis involving the IP address 170.72.169.30 conducted on September 5th, 2023. Here it is. Packet details, who is lookup, frame, protocol, source destination, the who is, the DNS, the threat, the connectivity, all timed out, the conclusion. Best regards. By the way, here's the report. Ha! There you go, right from the email. So it chained the email together with the GitHub and everything. All right, now we're not done. Now, what does this look like? What happened here? What happened here? Let me take a second to come back to the screen. Let me take a second here. What is going on, right? From that conversation that I sent it and the tone that I sent it. It fired off an email with a link to the GitHub, put the link in the GitHub to me, created it on GitHub in Markdown with a title generated from the analysis of the packet. Who is information, DNS information, ping, curl, trace route, right? Like, what is going on here? Let's take a look at what's going on here. What's really handy is I can trace all of this in Langsmith. So we're going to go into Langsmith here, and we're going to go for the last hour, and there's that run. Now, I'm going to talk to the Langsmith people. The input is the packet system. I wish I could change this to the user. That would be much handier from the UI, and I haven't figured out how to customize that. But there is user input here. But the output, right, this is the final analysis. The analysis of the packet capture is complete and a comprehensive report has been created. That's just a snippet of the AI answer, right? And you can see how much did this all cost me and everything? This cost 7 cents. Now, ask yourself, was that worth more than 7 cents to an enterprise, to the world, to me? Yes, that was worth. I would have paid $100 for that right now to do that video easily, right? It used all these tokens, 0% error rate, and I have the latency information, right? I could add this to a data set. I have some metadata. So let's take a look at the waterfall. This is where it gets really exciting. Now, can I zoom in? I don't know. Well, I'm going to collapse this to start with. I can't do that. Never mind. I keep thinking I can collapse that, and I can't. So I just want to show you at a high level what's going on here. And we will look at the trace. I'm going to go back to this. But we have our start, and the assistant calls tools that feed data back to the assistant that call tools that feed data back to the assistant that call tools, etc., right? The whole way through this chain, I can follow along. There's the human input, there's the pcap data, right? And this is going to feed the RAG tool, right? So if I expand this, we're going to start getting some tool conditions and some assistant data, but there's the pcap RAG tool. And what's really neat is that I can go into my vector store and see the shards of data. That is the pcap as JSON before it heads into the vector store. Okay? Or that's the vector that gets retrieved in 0.49 seconds. Right? Now the AI has the RAG, the reference, the frame of reference to analyze this pcap, right? So that's where it all starts, is with my initial pcap RAG tool that I wrote closing in on a year and a half, like almost 2 years ago now. The cornerstone of my work was the RAG stuff. So we keep going. Now check this out. It starts to cascade through the public tools, and in my logs, I have all of the information available to me here for each of the tools that it's running, right? Here, right? Threat check, not blacklisted. Curl, probably failed. Ping, probably failed. Traceroute, probably failed. But if I did one with Google, which I can do if anyone's interested as a follow-up, some of these tools will actually answer with data. Now, some of the other tools that it called was the create GitHub report. Now, this tool, I did not write it. I had nothing to do with it. I brought up the MCP server. I made a connection calling the tool from my LangGraph, and it went ahead and did all this stuff in Git. I didn't do any of it. I don't even have to know Git. I just say, go ahead and please make a file in Git, right? And then one of these is going to be the email. One of these is going to wrap things up. There's the email, right? The very last thing it's going to do, and there's the hyperlink. This took 1.99 seconds to send. I'm tired. I'm not even tired. Okay, so MCP to MCP a deep breakdown. I didn't mean to run too long, but there's so much that goes into what it's funny. The more difficult the back end is, right? It seems to lead to simplicity at the front end, meaning the user, who this is for. This isn't for me. I happen to be the person who made and connected these pieces. Forget that. Put me aside. People going to consume this can now simply say whatever they want and attach the PCAP, and the MCP servers are going to do remarkable things. Right now, you can put it in a GitHub repository. I'm going to scale this and hopefully add a Google Drive, add a Postgres, go MCP shopping, right? So, I am here for questions. I'm here for answers. I'm here to help educate the public on artificial intelligence and the next coming era. Please reach out to me. I've been doing this for a while, and this is sort of where people thought it might go. Because what you can see are some competing things here. We have different LLMs starting to emerge that are all very powerful and challenging each other for supremacy. We have frameworks that are emerging. We have every day an explosion of new tools, right? We can't have this. We can't have it. We have to have everyone collaborate, say, okay, here's how we're going to do it. Here's our MCP server. Here's our specification and the tools we offer. And you can integrate it with your MCP client or servers, however you want to look at it, right? We need to collaborate on this because it's going to be like the World Wide Web, except for artificial intelligence agents and tools. You've seen what I've done with it. And I'm telling you, there are other people who are way more intelligent than I am working on this right now. Way more capable people who actually studied this stuff. Okay? So I'm going to wrap up there. I don't mean to ramble, but I am here to help. And if you have any questions or if you have any comments, please let me know. I'm working on getting the source code in a state that I might be able to release it, but we'll get to that bridge when the time comes. All right, thanks again. Enjoy MCP shopping.